just a little background on maybe more on the technical side of the platform. We often find that data in tables is holding the organizations back that we work with. And data in tables have a few downsides. It primarily results in lack of context, an inability to apply semantic meaning and understanding to the data, as well as keeping it stovepiped and siloed and disconnected. And this all hinders the adoption of artificial intelligence into our workflows. And so what the platform is really designed to do is it's designed to interoperate with all of your existing systems. It uses cloud-native microservices architecture, so it can deploy anywhere from a laptop at the edge to main enterprise system on your premise or in a cloud, air-gapped, wherever it needs to run, so it can deploy anywhere. And it gives you a few advantages in that it allows you to get your data in and get it connected. So first we connect all those disparate data systems, and I'll show you what that looks like in a second here. And then we apply the knowledge layer and then build intelligent systems based off of that. What you're looking at right now is our default dashboard. It is meant to be a collaborative environment, so analysts and groups typically work in projects. You can share projects, so a project is basically a collection of data that's relevant and meaning to you. If I jump in here to FBO, this is an example of combining structured and unstructured data, where we've taken basically beta.sam.gov. Now it used to be FedBizOps, and taken all of the RFPs that have been put out, or RFIs, all the different procurements that are out there, gone through those and extracted out the contacts, using natural language processing, had it process out the contacts, the department, the group, and form it into this knowledge structure, so that it's, instead of being unstructured, it's more of a useful structure. So in this group, in this picture, or in this workspace, what you're seeing are, the circles are your people, places, and things, and the lines between them are the context of how they're related. And so in this case, if we have, Army, which includes our Office of Army Contracting Command, and we have Frank and Carolyn that are both a part of this office, and Carolyn's responsible for the air-launched effects, and Frank is, the contact for the USA's effectiveness in delivering Civil Works program, and all of these are dealing with artificial intelligence. So now we can start to expand out, outside of Army, and connect also in. We see that from these other programs here, the research interests and directed engineering modeling, we start to connect across to the Air Force as well, and we have other agencies and other divisions of the military and other groups that are all looking for, conceptually the same thing. And so what this allows us to do is start to provide, overlap analysis, similarity analysis, and be able to say, okay, who's trying to procure the same things? Who should collaborate? This is what we're doing for Air Force with AFWIC, helping them identify certain concepts that they're interested in Air Force-wide, and then identify the programs that are having objectives to accomplish those concepts, like redundancy, or consistent resilient network infrastructure, things like that. And you can start to say, oh, you should collaborate, you should converge because you're duplicating effort here, or this is similar, it's not overlapping, but you should work together instead. So it provides a structure. This graph structure is essentially becomes the knowledge and the mind, the memory bank for our AI. So when we do AI, we first get your data out of all the different tables that they're sitting in around your organization, bring it in, get it connected, enrich it with meaningful context, and then use that to train different AI models. And so when you bring data into a knowledge context, it's the first time that, and you apply that semantic meaning, it really allows humans to all agree that we're saying the same thing, that we understand things the same way, that we can have, it's all governed by this knowledge model where we can say, okay, we're going to have a person, and we're going to have an organization, and we're going to have phones, and we're going to have requirements, we're going to have verifications, verification details, all of these different concepts for the people, places, and things that matter to us in our mission. And then we can look at how they are related to each other in the relationships. And those relationships are where the lines between them, that's kind of the context for how they're connected. And that's where we get a lot of analytical meaning and how we start to understand our data in new ways, because a lot of the questions we ask are very relationship-centric, but traditional data approaches don't allow us to answer those questions in a meaningful time frame, let's say. So the data format that you see here visually is how the data actually is connected. We don't rely on indexes to do traversal, like traditional relational databases or other document database structures do. And this is a very efficient storage format. We've had use cases where we've had customers that have gone from 55 terabytes to 33 gigabytes when they move from a storage structure that looks like Excel to this type of storage format, simply because it's reducing all the repetitive and redundant data that is required when you use indexes to connect your data in this way. So it provides a lot of advantages from that aspect as well. Additionally, if I step back out here to this project and we go down to a demo that we did for Transcom, so this is dealing with routing and shipping information, and we have much of the data connected around the bill of materials and the different items that are included in all of the transit and how it's being routed around the world. The other type of visualization, because not everyone wants to look at just the kind of network view where you see the kind of raw people, places, and things and the way they're connected, but sometimes it's helpful to see a geospatial view. So the platform also provides geospatial where you can get in and see the different, in this case we have the ports plotted here, and we're overlaying not just the ports, but the thing that we really cared about in this analysis was the delayed bookings. So which ports have the most delayed bookings. So the statistical view, it lets you link up and understand not just the data that you're seeing in the network, but maybe see different slices of that, so you can look at 6-month in transit delay, do some more of that statistical analysis, or see plot more information around booking data or specific items of interest, or what are the top 10 routes in transit, those types of things, at least in this example. So it gives you a lot of flexibility on the visualization and the way that you look at your data. Another one that's kind of a use case is if I'm an analyst and I'm tasked with looking at a specific person, for example. In this case, I'm going to use Tashfeen Malik. And she was one of the San Bernardino shooters. And in this case, if USCIS is trying to get a, kind of just research her for a visa, if she's applied for a visa, all of the data that gets connected in from the different sources becomes searchable. So I can go in and search across it searches across all the categories, so articles, knowledge graphs, etc., persons. Can add her to my workspace. And then one of the things that, with the way that we do, combining kind of the graph theory capabilities that we get from the native graph, as well as the AI analysis from the different models, is we can do pattern of interest detection. And what I'm going to do now is something that would normally run in the background, but I as an analyst can use this show me, and what it is it's going to start from any person and look for a connection to an illicit organization. And so in this case, when I run that, I can do that in real time, and it's very fast and snappy just like that, because the data doesn't rely on indexes to do traversal. So we can start from Tashfeen Malik, find her social account, follow that through Abu Bakr al-Baghdadi's social, and back to the leader of the Islamic State. And so immediately, I would want to take a look at her and dive a little deeper, and if I do that, this number here represents the number of the information that we have on her. And so I can expand out kind of the different connections here and see the spouse. So Tashfeen Malik has the spouse, Saeed Rizwan Farouk, previously located in Saudi Arabia, currently located at this place in San Bernardino. Has a couple of different alternate names. She's known as, has a phone number as well. And so we can start to see the information in the system that's been collected from these different data sources, whether it's social media or news articles, and be able to combine that with, also maybe internal data that exists. On the kind of natural language processing and the news side of things, we do have a live, one of the things that we have hooked up here is we do consume about 30 or 40 different news sources on a consistent basis that are all in about 10 different languages, and those process in and enable you to see and read this information. So if this is, in this case it's news, but it could be any kind of textual source information that's pulling in, and it does similarity analysis. So if I want to see articles that are similar to this other article, it'll go ahead and I clicked on the similarity. It went and pulled similar articles, does sentiment analysis. I can read the detail of those, extracts the different topics. So these are things that are, what was the content of this article about. It does the translation from the language. So we have the pipeline in place to enable you to continue to train and evolve AI models for different processes. The way that this works is we'll usually start with a basic AI model that is, in this case for natural language processing, we use BERT, which was published by Google as kind of open source, uses TensorFlow, and then we train. So that's been trained on, kind of at a foundational computational linguistics level in 104 languages for basic computational capabilities around linguistics. And then we take that and we do specific feature training for different parts of natural language processing that are needed, like, identifying named entities, identifying relationships between them, part of speech, sentiment, other things like that, the translation as well. And then those models are given to our customers, and we further refine them based on your specific data. And so when it comes to data and information, you own your data. When data gets put into our system and our architecture, it is your data. We use an open data format, so it's easy to get data out. You're not locked into it. You own derivatives of the data as well. And the same way with the models. So when we train these models that are specific to you and your data set, your problems, your corpus, whatever the problem and domain that the platform is being applied to for you, then you get to have those models, and they become your derivative works of that. And so it's not something that we're taking and keeping and holding back. So there's kind of three layers. We start with a base layer of the model that's open. We train it for specific features, and then we further refine it based on your specific data and your specific use case. Yeah, and I'll just point out here the last one was from about 30 minutes ago. So we kind of have consistent live feed flowing in across these different sources. And in this case, we've assigned different trust scores to the sources, whether it's Al Jazeera or BBC, Fox, etc. Any questions on any of this?
How do you assign a trust score? Who makes that determination?
That would be something that you get the flexibility to do. So if you have certain sources that you're getting information from, and you want to, say how much you trust that source, then that can that gets applied and that gets used whenever, we're the systems and algorithms and even humans are making determination of how do you, how hot, how much do you trust information you've received? How good is that information?
Okay. Thanks.
Is the main feature of this tool the natural language processing capabilities, which seem pretty robust, or is it the uh, you know, AI prediction capabilities, or the graphical capabilities, or is it all the above? Just to have like a dashboard and have nice visualizations all in one place.
Yeah, so the dashboard is one view into the platform. The real value of Gray Raven is the platform that sits underneath all of this. So this is one way to look at it. Some of them, some will just integrate with the API directly and may not use this interface. It's our default interface. It often gets customized for your specific workflows, but it does provide a starting point. And the way that we think about, I guess, from a very technical perspective is, the graph providing knowledge and context around your data. So being able to ingest and connect the data into this knowledge structure and get it represented in context then allows us to have context-aware AI that stays synchronized. So we use an event-driven architecture where as data in the graph changes, the system pushes out and updates the AI models as well as search so that everything stays synchronized. So both your humans and machines are all working off of the same understanding of the data of the mission in context. So the strengths are really the totality of the platform and being able to bring together graph plus AI, and then we do have a fairly strong natural language processing component. And so doing graph-based ML and graph-based machine learning, or graph-based machine learning and graph-based natural language processing, so that the two graph is driving all of those so that you can extract graph embeddings, because the graph gives you basically structure, distance, and context for your AI models. So it's a much more complete picture of the world that the AI is being trained on, compared to if you're simply using basic vectors that you get from traditional systems that you may be putting AI on top of or asking AI to use to get its data from.